So it's going to be coming into the summer in the UK now, in the next couple of months. And then the issue of staying in the van is going to change from how to stay warm to how to keep the thing cool. Obviously nailed it with the warmth, diesel heater, easy hit, nice and cheap, simple. But keeping cool, different set of problems. So couple of things. There's, depends what you want to do. You can obviously put a roof vent in with a fan, create a bit of airflow, which is fine, which is great. However, we've had a couple of really hot summers, where we're well over 30 degrees, and we're not used to that over here. All right, you acclimatise after a couple of days, but sometimes your van just gets so hot during the day, it's never going to cool down. It might be quite cool outside. You open the side door, blah, blah, blah. But you might not have the option. Sometimes you just want to cool your van down quickly. So this is where the sort of discussion of air conditioning in vans comes in. Obviously, you can go and buy a big expensive system and stick it on your roof. But if you don't have the budget or you don't want that rubbish on your roof, you're kind of limited. So there are some, if you want to install air conditioning, you've got to fit a compressor driven off your engine belt. You don't want to be running your engine if there's other people around. And then there's systems like this, the Fresair, which just runs off 12 volts, about 10 amps. Yeah, good. It costs an absolute arm and a leg though. I'm not saying they're not good, but there's got to be a sort of simpler option out there, and a lot cheaper as well, for if you just want to cool the van down. So other people have tried where are they, this sort of stuff here, based on a tech thermal electric cooler. Absolute waste of fucking time. These do jack shit. And you can get similar sort of systems which will cost you £300 or £400. They're only 50% energy efficient. They don't actually do a lot. It's the same technology that you have got on your sort of electric plug-in cool boxes. It's a little sort of it's the Peltier effect. So you use Peltier coolers, but they're very, very inefficient. And if you don't want to run your engine, you're really, really looking for something that is going to be fairly efficient. So if you're just looking to equalise the temperature between inside the van, the heat that's built up, or the heat that might build up if you're sleeping in it overnight, because you'll create, a few hundred to a few thousand watts depending on how much thrashing about you're doing. I've been looking at this little idea, which was discussed with my pal who's an aircon engineer. So if we can equalise the temperature between inside and outside quite quickly and maybe stabilise it, hey, well, that's got to be a good thing. And if we can do that at quite low cost, well, even better. So the sort of idea is based around something like this. This is 45 doll hairs from the usual scumbags, and it's basically an add-in heater matrix for your car. It's pretty crusty. You've got it's a fluid thing, so how this is designed to work is you've got a hot flow coming in from your engine coolant, and then there's a fan and a little radiator here, or some fans, and they'll just blow they're going to blow the air from inside the cab over the radiator, which is heated by the flow in of hot engine coolant, and then blast it out these ports here, which can obviously be directed places. But this can also work, it's basically a heat exchanger, so this can also work in reverse. If we introduce cold liquid in there, colder than the ambient air temperature in the van, then that heat should be transferred off and carried off down these pipes here. So this is the sort of idea we come up with. So here's the heat exchanger here. Sorry, this is another unplanned and poorly researched video. But yeah, so here's the heat exchanger here. That's the unit we just saw. And the hot fluid, or the heat is transferred into the fluid in this unit here, taken down here. Now we've got to lose it. So the idea is to have like a radiator basically with a fan on it. Could be mounted on top of the van, could be mounted on the side. I'm going to give this a try underneath the van. And that will dissipate some of the heat from this fluid to the outside. Now, this is only ever going to be temperature equalization. This is not air conditioning. You know, you cannot dump more heat, you know, outside the van than is the ambient air temperature. You can only ever equalize that. So if inside the van on a hot day ends up, you know, 30 odd degrees, but cools down at night to say 21, 22, that's the best you're going to get. You're never going to be able to cool your van cooler than the ambient air temperature. So yeah, this was the idea. These so I had a wee look on the usual scumbags websites. That's fairly cheap. You can get hold of sort of a radiator here. Apologies for this is just shot on the phone. This is an oil cooler radiator, so it's got the small you know, the small ports here, which matches the sort of tube diameter, and you can just use rubber hose, and the sort of mounting brackets here, so fairly easy to mount underneath the van, probably at an angle facing away from or facing towards the rear like that, so any stone chips any stones bouncing along the road are going to be less likely to do any damage. And then just some sort of cheapo radiator fan, you know, what's that, about 20 quid, something like that. So so that's the general idea anyway. So it'd be interesting to see what comments people have on this. I'm going to give it a try anyway, because if I'm sort of halfway through putting together a bill of materials till I got bored, you know, and we're up to about 120 quid there. But then we add in a fan, a relay, some sort of controller, which I'll base this on an Arduino, and some cheapo temperature probes. Yeah, 150 quid. Worth a little try, and a sort of bit of a good fun experiment. So the couple of sort of thoughts on this. Here's a quick look at the power it's going to draw. So we're looking at probably about 10 amps total. We're not going to work to run 10 amps all the time. It's going to flatten batteries fairly quickly, and you probably don't need to. So here's the thing. There's going to be a point where this is going to be extracting heat, and the radiator's going to be dumping it, like when it first starts up. And you know, you're not going to need the fan on. You know, out of these devices, 2 amp to run the fans on the heat exchanger, about 1 amp, if that, to run the pump, being generous. And but the fan's 80 watts, so you know, about 7 amps. So the fan being the biggest thing on this radiator, that's not going to need to be running all the time. So in the interest of saving our batteries, if we measure the temperature of the hot and the cold pipes, and then feed those temperatures into an Arduino or similar microcontroller, we can do a bit of maths, and what we can say is, if we scroll down here, and also need to have an air temperature probe inside the van. Well, we don't need to, but but imagine we do. So if the air temperature in the van is greater than the set temperature, assuming that we can set the temperature, then turn relay 1 on. Now relay 1 is for the pump and the heat exchanger fans. So imagine that starts extracting heat. It's coming down to this radiator, and after a few minutes, there's not going to be much difference between the hot and the cold, i.e. it's not really dumping much heat and needs a bit of assistance. That's when we can chuck another sort of bit of code in. You know, it'll be a case or a switch statement, something like that. Non-blocking based on timing. And it'll be if probe 2 minus probe 1. So probe 2 is the, so probe 2 is the hot pipe. Probe 1, temperature probe 1 is a cold pipe. So if the difference of them is less than 5 degrees, I'm just taking this as for the sake of argument, then turn relay 2 on. Relay 2 is for this fan. And then the fan will kick in, and we should be seeing a larger sort of difference between the temperature in the two pipes. So i.e., you know, the fluid being returned back up to the heat exchanger in the van is a lot cooler than what's coming out. And then, yeah, so that's the sort of basis of that. And then hopefully once that sort of, that difference increases, then the fan will kick off, but the indoor heat exchanger fans will continue to run. And then hopefully at some point, once the van cools down, based on the indoor air temperature sensor, then this unit here can kick off and it'll knock off the relay for the pump as well. So that's the sort of general idea. So yeah, I'm going to give this a try. It's going to take about a month for this little heat exchanger to arrive from overseas. You can buy them from UK suppliers. They're about 100 quid more. I'm prepared to wait. I've got plenty of other stuff to do in the meantime. And, you know, the chances are even if I ordered this and it arrived next week, it would just be slung in a pile somewhere along with all the other things I can't be bothered to fit to the van. So this is, at this point, this is just an idea to give other people ideas, and you know, the more heads banged together, the better. So if you like this, or if you've got any other sort of takes on this, or any experience in this kind of thing, chuck it in the comments down below. Let's try and get some people sort of working on sort of some way where we can all, you know, for not a lot of cash and not a lot of drain on our leisure batteries, you know, make a little bit of a difference over the summer to our vans. Okay, thanks very much.